Our next question is from GATE 2015 process calculation for 2 marks. The schematic diagram of a steady state process is shown below. The fresh feed to the reactor consists 96 mole percent reactant A, 4 mole percent inert in this, right? The stoichiometry of the reaction, A gives you C. A part of the reactor effluent is recycled. You can see here, right? The molar flow rate of the recycled stream is 0.3 F. The product stream P contains 50 mole percent C. Here 50 mole percent C. The percentage conversion of A in the reactor based on the entering the reactor, based on A entering the reactor at point 1 in the figure. Right? We just need to know the per pass conversion. Per pass conversion only, right? We have two types of conversion: overall conversion and per pass conversion. Per pass conversion is only conversion in the reactor, and overall conversion depend on the for a complete conversion. Actually, how much A is entering, how much A is exiting, such like this, right? So now we just need to calculate the conversion for this reactor actually, right? So let's start with the solution. Basis, I am taking the basis, let F is equal to 100 mole per second. There is no problem if I take this. At steady state, you know that whenever there is a steady state, F input should be equal to output since accumulation is 0. So at steady state, F is equal to P, and P should be also 100 mole per second since F is 100 mole per second, right? Next, you can see here I am mentioning here 2 points also, G and M. They have mentioned it 1, and I am mentioning here G and M, right? So now we will see recycle R. You can see here they have given recycle R 0.3 into F. How much feed we enter? This is a 30% of F, right? So it should be 0.3 into 100. You can see here it should be 0.3 into 100. It will be 30 mole per second. Now there is no problem, right? Now they have given one thing also. They have given 50% C in the product. 50% C is there, and 4% is inert, right? 4% in inert. And so mole fraction of A, what will be the mole fraction of A in the product? It should be 46%. It should be 100, or I am calculating in mole fraction, then it will be 1 minus 0.5 minus 0.04, right? It will be 0.46. Now there is no problem with this, right? Next, stream M. We will come to the stream M. Now remember one thing, whenever there is a separation, this is separating point, we are just separating this stream. So remember one thing, composition will remain same. Composition will remain same in 3 streams. Composition, we know this. We know the composition of P. 50% we have C. We have 4% I, that is mean inert, and we have 46% A, right? So similar composition will be there also, and similar composition will get there also. Remember this concept, it is very important concept. Whenever there is a separation, the composition will remain same. There is only a splitting of the streams, right? So now stream M, there is 50% C in the stream. Since we have 50% C in P, 4% inert in M, and again mole fraction of A I have already calculated, but I am writing it for your convenience. Mole fraction of A, or you can say percentage of A, should be 46% in M, right? Now come to the point G. If you see here at point G, 2 streams are coming, F and R. F plus R should be equal to G, right? I know the F, that is 100 mole per second, and I have already calculated it as it is 30 mole per second. So it should be G should be 130 mole per second, right? 130 mole per second. According to stoichiometry, it is given as A gives you C only. If A gives you C, so from A gives you C, I can say G gives you M, since there is no change of moles. 1 mole A gives you 1 mole C. if G is 130 mole per second, M should be also 130 mole per second. There is no problem with this. Suppose if there is A gives you B plus C, that means 1 mole gives you 2 moles, 1 mole of B, 1 mole of C. So there will be change in molar flow rate in Gm and M, but they have given A gives you C only, 1 mole gives you 1 mole C, so there is no problem. So we can say that G should be equal to M. G will be equal to M, and I know the value of G. If I know the value of G, then M should be 130 mole per second also, right? There is no problem. I know the composition of M, I know the composition of M, and I know the molar flow rate of M. So now component A in the stream, I know that is 46%, so it should be 130 into 0.46, 59.8 mole per second. Flow rate of recycle stream R, I have calculated it earlier, that is 30 mole per second. I have already told you that composition will remain same. Component of A in feed stream F, that is into 96 mole per second. Why it is this? Since they have given one thing, they have given the fresh feed of the reactor consists of 96 mole per cent reactant A and 4 mole per cent we have inert, right? There is no problem. So component A in feed stream F is equal to 100 mole into per second into 0.96, 96 mole per second. Now from recycle we are getting 13.8 mole per second A, and from feed we are getting 96 mole per second. So that means total A in stream G, what will be the, you can see here, I know how much A is entering from here, how much A is entering here. From here we are getting 13.8, from here we are getting 96 mole per second. So component A in stream G will be sum of these two, right? 13.8 plus 96, it is 109.8 mole per second, right? Now how will be the final answer? Since I have already calculated component A in stream M, that is 59.8 mole per second. So you know that what will be the conversion? What is the conversion actually? Conversion is given as how much A is entering, moles of A entering minus moles of A exiting divided by moles of A entering. So ultimately I can say 1 minus moles of A leaving divided by moles of A entering. So from this conversion is 1 minus 59.8 mole per second divided by 109.8 mole per second, that is 45.53%. This will be the final answer. Actually GATE 2015 was the toughest exam in chemical engineering, right? So every question will take some time, right? So thank you. Please make sure to like, share and subscribe my channel. Thank you.